Hello everyone, this is Rashida. Welcome to my channel. My today's video is going to be on wide and deep neural network. Before we dive into the code, I will give you an overview on why we need wide and deep neural network. So as we all know that we want the neural network to generalize well so that when you input unseen data to the network, it can predict the target reasonably well. So we do not want the network to memorize any features. But some features can be really closely related to the target variable that they can directly go to the output layer. They don't need much transformation or they don't need to go through much mathematical calculations. But some other features can be not so closely related to the target variable and they need to go through a deep neural network to be able to predict the target well. For example, in a movie recommendation system, if a person or a user watches a lot of action films, you don't need too much calculations to recommend an action film to that person. But when it comes to recommend more diverse kind of films, it needs more work. In that case, a deep neural network will help. In those situations, it is good to use a wide and deep neural network where some features can go directly to the output layer and some features can pass through a deep neural network. Let's dive into the code to see how we can achieve that. So I'm using California housing dataset that you can directly import from scikit-learn library and then using frame test split the data for training and testing purpose. You see, we have total of 8 features and we will divide them to the wide and deep portion of the network. For the wide portion, I'm taking first 3 features. And for the deep portion, I'm taking the 6 features. And you can see that third feature is overlapping. Third feature is in the wide portion and also in the deep portion as well. So this is important to remember that the wide portion and deep portion can share features. Okay, you can pass through all the features for the deep portion and all the features for wide portion as well. That also works. So they don't have to be exclusive to wide or deep portion. We need to do the same allocation for the test portion as well. And then let's develop the model. We will use the functional API method. If you haven't watched my video on functional API, please watch my last video. I have the link in the description box below. So first, we will define the input. So wide input, tf.keras.layers.input will pass the shape. So wide input, we have the shape of tree, right? We have 3 features. So we only need to put the number of features and the rest will follow. tf.keras.layers.input again, and the shape is 6. We have in the deep portion the 6 features. You can see it from here. In my other TensorFlow videos, I never did the data normalization. Today you will learn how you can add a normalization layer, normalize your inputs. So wide normalization, instead of typing this again and again, I'll just copy it here. Layers dot normalization and deep normalization dot normalization again, norm layer wide. So in this normalization layer, I will pass through the input wide normalization. So wide input and norm layer deep. Now deep normalization and deep input. Actually, this is input, so it should be input. Oh, that's so funny. Normalization is done. I will add the hidden layer now. So first hidden layer, hidden one, as usual, tf.keras.layers.dense. I want to use 50 neurons and activation of ALU, and you pass deep input. Okay, I will use norm layer deep, so normalized deep side of input, norm layer deep. The next layer, hidden 2. Again, I will just copy this whole thing, paste it, and instead of 50, you can keep 50 or I will try 30. Okay, and hidden 1. Now I will add a concatenation layer. It will be tf.keras.layers.concatenate. So what we are going to concatenate in a list, put hidden 2 with hidden 2. I will put this wide normalized layer that we haven't used before, norm layer wide. Finally, the output layer, tf.keras.layers, and you know the output layer is another dense layer. Because this is a regression problem, because in housing dataset, we are predicting the price of the housing, the properties, right? So this is a regression problem. So typically in regression problems, our output layer neuron is 1 because you predict one output for one row. You pass concat, this concatenation layer here. And in the concat layer, we have the white portion that is just normalized and not transformed any other way, and the deep portion that passed through this hidden layer 1 and hidden layer 2. So model development is done. For this normalization, we need to do one more thing, that is just extracting the parameters for the training data. Let's do that. Wide normalization dot adapt x underscore wide. Then deep normalization, we will do the same thing, dot adapt x underscore deep. You remember x underscore wide and deep that we defined here? Yeah. From them, we will just adapt the parameters in this normalization layer. We define an optimizer, tf.keras.optimizers.atom. I'll pass a learning rate 1e-3. Now build the model tf.keras.model. We have to pass inputs and outputs. For inputs, we have to put wide input and deep input. Remember wide input and deep input that we defined here, the input layers, 2 input layers we have. So that's what we have to put as input. And outputs is simply output. Here we have this output layer defined here. Let's compile the model, model.compile, loss. We will use MSE, mean square error, optimizer. Optimizer is optimizer that we defined here. Actually, instead of optimizer, I will type this way, that way. It will be more clear. And matrix, root mean squared error. And the spelling mistake again. run the model. Model.fit. So the input data, that is x, y, and x, y, and x dip. Remember x, y, and x dip, this one that we defined in the beginning. And then y train, epochs training, validation split, 0.2. That means that 20% of the data will be used for validation. Okay, let's run. Okay, model training is done. You can see the root mean squared error for training. In the beginning, it was 1.42, then for validation 0.88, and then slowly it became 0.64, 0.64, and loss 0.4, here 0.41. It's pretty close. Not much overfitting, so it was pretty great model. Model dot evaluate x test white and x test deep. The test data that we kept separated for evaluation purpose at the beginning, we're going to use that. You can use this test data here in the validation portion as well, instead of using part of the training data for validation. But it is a good practice to keep the test data totally separate. So the test data is completely unseen to the model. The model have never seen the test data. Test. We see the loss 0.39, almost 0.4 that we have here, and root mean squared error 0.62, which is pretty close that we have seen in the training and validation data as well. So it can generalize well for totally unseen data as well. Well, that's all for today. I hope you can use this technique for some of your own projects and get some good results. Please like, comment, share, and subscribe. Thank you so much for watching.